We are discussing about derivatives. What is a derivative? So specifically, we will be talking about derivative at a point. What does it mean actually? How do we define this? So as a definition, a derivative at a point is just a limit. Derivation or derivative at a point is just a limit. So what does it mean mathematically? So let us assume that there is a function fx and this is a real valued function. That is, it is defined in certain interval, certain domain, and this interval in this which it is defined. So whatever you give between a and b, you will get a value of y if you put some value of x in between a and c. So let us say this x which you are putting in fx is c is belonging to a comma b, and this is an open interval. So we are talking about function, and this fx is said to be differentiable or derivative. What is a derivative? At some point c. For example, you have a domain, so say an interval from 2 to 5. You take a value 3 in between. Now say some function y equals sine x. Now you want to put sine 3. So you are going to get a value of y. So then you'll say this function is differentiable or derivative exists at x equal to c, that is 3 here. So this function is differentiable if and only if the condition is what? The condition is limit. Limit must exist. For example, limit x tends to c, for example x equals 3 here, fx minus fc, that is, well, taking the value of fx and then the value at particular point 3 in this case, and x minus c. So this limit should exist finitely, and then we say this fx is differentiable, it is existing finitely. So this limit is called as derivation, derivative, or differentiation of this function fx at some point x equals to c. If it is giving some 0 by 0 form, you can take the limit. If it is okay, then you say that this is the derivation. This is the only derivation. We will talk about its physical, interpretation, etc. But basic is derivative is this only. It's only the limit. It is only the limit, nothing else. So let me take you to the different notation of this fx, f dash x. That is, this whole bracket inside is f dash c. This is a representation. Dash represent derivation. Then you can also call it as capital D of fc, or also call as d by dx of fx. And what is fx? Y, as I just took. So dy by dx at x equals c. So if we have any differentiation, essentially you are doing what? This f dash c, that is value of this fx at some point c, is limit x tending to c and fx minus fc by x minus c, right? So when we say that this is 0 by 0 and we have changed it, or we are able to show that it exists, there is no formation indeterminate case, then we say this is the derivative. So in this whole discussion, we will say that this is fx function is differentiable, that is in this certain domain, it's differentiable, and this limit will take it as, when we discuss limit, that is the left hand limit has to be equal to the right hand limit, and it has to be equal to the function at that particular value, right? So we say c minus we will take, c plus we will take, that is c plus, sometimes we will put c plus h, other time we will put c minus h, and then we will try to equate and we will say it is equal. Then we say that the limit exists. As I am saying, c plus c minus is exist, x plus h sometime, x minus h sometime. So this limit we have already seen. But this limit we are applying, and we are saying it that this fx minus fc by x minus c is there. That is your differentiation. Okay, I'll tell you an example. Let me tell you an example, and then you will understand what we just discussed. Okay, so we have, see, we have a function, say fx, and this fx function is x square plus 1. Now, as I said, you have to have some c value, that is some value, value in the range domain. So you have 2. So you have to find out the derivative or derivation at f2. So f dash 2 we are going to find out. As I said, it's just essential limit. So you say c plus or c minus. So let us take c plus. Okay, we are going to put fx minus fc by x minus c. This I already told you. You have to apply limit x tends to c. In this case, c is 2. C is 2. So x tends to 2, and I'm doing it for 2 plus. That is 2 plus h I'm going to put. So in place of x, you are going to put 2 plus h minus fc, of course c is 2, and divided by 2 plus h minus 2. So this is x minus c. In place of x, I am putting x plus h. So this is extending to 2, as I said, extending to c. But since we have put x as 2 plus h is tending to 0, because x minus 2 if you take, and if you say that x is equal to 2, h is going to be 0. So limit h tends to 0 now. Now what are you going to get? Wherever you have this 2 plus h, in x, replace it by 2 plus h. So 2 plus h whole square minus f2. So f2, you have to put, in place of x, you are going to put 2. So 2 square plus 1. I'm just replacing this x with 2. So 2 square is 4, 4 plus 1 is 5. And this is 2 plus h square plus 1 also. There is one plus 1, I'm just going to add this. So you have h square, I'm opening it, a square plus b square plus 2ab formula. So h square plus 4h plus 4. This is also plus, I'm just going to change it. So a square plus b square plus 2ab, and also plus 1 also. So what do you get? A square plus b square, this is 2 square, that is 4, plus h square, that is h square, and 2 into 2 into h, 4h. So 5 and 4 plus 1 gets cancelled. So h square plus 4h it is. Now h square plus 4h, I'm just going to change this plus. So h square plus h, now you can take h common, and then h can get cancelled. These are all plus, as I just said. So this h gets cancelled, you have h plus 4, and now you apply the limit here. Limit is h tending to 0, so h is going to be 0. And 0 plus 4 is 4. So you are going to get the value, this is f dash 2. F dash 2 is 4, that is differentiation of this function at 2 is 4. So what are you going to find out? In f dash, you are going to find out d by dx, dy by dx, and y is fx here. Okay, then what you have done, you have just done the limit, you have taken the limit, which is extending to 2. For what? f2 plus h minus f2 divided by this x minus c, as I indicated you earlier. So this is the derivative at a point. It was 0 by 0 form earlier, but we proved it that it is not 0 by 0. We have a proper limit here, left hand limit, right hand limit, and that is going to be 4, and that is the differentiation value. Okay, and we'll see the physical interpretation of this derivative at a point. Okay, derivative. What do we mean by a derivative? We talked about a derivative at a point. That means at particular point, what is differentiability, what is derivative? So the crux of the story was that when we have a function fx, it's a real valued function, and you are talking about an interval a comma b, some value at c in this interval. So if we are interested in f dash c, that is you want to find out a derivative. So essentially we are trying to find out the limit. So this is limit x tend to c, and simply the subtraction of fx minus fc, that is the value of function and the value of function at this c point, divided by the two values, the x value and the c value. This is the derivative. But this is mathematics. What do we understand when we say that this is a derivative? What does it mean when we talk about real life? We need to know the physical interpretation. We need to understand the geometrical interpretation. That is, just by knowing this formula, we can just solve questions. But if we understand derivative, then we'll be able to solve it with all our logic, right? So let me give you an example first. For example, if something is having 2 kg weight, the rate is say $10 for 2 kg. For 4 kg, what it will be? Twice of this. For 2 kg, it is $10. For 4 kg, it's $20. Now you will tell me about 8 kg and 10 kg also. It's clear. 10 kg, if it is for 2 kg, some say rice. For 2 kg, it's 10 rupees. So 10 by 2, 5. 5 into 10 is 50. So you know that this is 50. So that means if you make a graph or you have any real life situation and everything is going fine without any deviation, if something is a straight line, that is, if I ask you that you know about 2, that the cost is $10, tell me about 6. You can plot it. You can easily tell by the observation. That is, if it is 2 for 10, that is 10 by 2 into 6, that is 30. So for 6 kg, you can say kilogram, that is $30. So it's quite easy for anyone to answer this question. If it is straight, if things are very straight, if a vehicle is moving, now the average speed, say it's 40 km an hour, it's not going 30, it's not going 50, it's always 40 km an hour. In 1 hour, you will surely tell me it will be 40 km traveling, 2 hours it will be 80 km, 3 hours it will be add more 40, 120, so on and so forth. Now everything is fine up till now. When we are talking about a function, there are different type of functions. Functions are everything, that is, if you are writing y equals fx, whenever you are putting some value of x, you are getting some unique value of y. For example, y equals 2x, we put x as 2, you are getting y as 4. So you are getting a function, you have a function, you are getting proper value. But the situation here is not these ideal cases. When everything is fine, everything is going wonderfully fine, we have no problems. You and me, anyone can tell this. But if the function is e raise x, a raise x, log x, and the combination of logarithmic and these kind of functions, so the function result may be like this, then what will you do? Now if I say you that, okay, at this x, some 1 hour, 40 kilometers, as we discussed, can you tell me that in 2 hours you will be 80 kilometers? In 2 hours you will travel 80 kilometers? No, you cannot tell. So you need to have a tool. You need to have something that whether we have a straight line, whether we have a different, curvier line. If I give you a tool that I can find out that in a curve also, this kind of situation, which I was easily able to answer previously, I can find out a perfect value or not perfect, near perfect, then the problem will be solved. So this is the physical interpretation. Mathematically, let us understand this physical interpretation now. Again, I'll tell you a story now. Now we are traveling from point O to point, say, X. O is source, X is destination. Now say a vehicle is moving here. So when a vehicle is moving, it will have some speed, right? It will have some speed. It will take some time to reach point to A, point B, point C, and it will travel a certain distance. All these entities, quantities, will be associated with this traveling, right? So now I can ask question about speed, time, and distance. Any other question I can ask you. Are you able to tell me that at certain point, what will be the speed, what will be the time, what will be the distance? That is, if I say that I give you a point precisely, that this is the point P, I ask you what is the value of speed at P, tell me. If I say you tell me the time at P, you will be able to tell me. For example, you are going to Delhi to Agra or some X provided destination. So if P is the point, and if you go to a Q point, what will be the time? What will be the speed? What will be the distance? These are my questions for you. I don't know the speed. It's not an average speed. It's not a proper constant speed. It's changing. Sometimes you will say, so stay. Sometimes the tire gets punctured. Sometimes something else may happen. So now this kind of questions can be answered by derivation, by differentiability. So let me give you some points now. From here to here, say you reach in 1 hour from O to P. From O to Q, let us say 1.5 hour or 2 hour. It's not possible that reaching Q, it will take 1 hour, reaching P, it will take 2 hours. It will never happen because P is coming before Q. So 1 hour for P, another 1 hour for Q. That is in all 2 hours for Q. So it's dependent on time. I gave you the time. So time will increase as the distance will increase. So let us say at P, we have certain time t0. Let us assume it to be 1 hour. Now when you go to Q point, you will add some time to this t0. That is, as I said, 2 hours. So you have to add 1 to this. 1 plus 1 is 2. So actually 2 is nothing but 1 plus 1, and 1 is what? T0, and h, that is that distance you have traveled, is 1. So I'm saying from P to Q, you traveled the distance h. H is a distance. And the time at P as t0, the time at Q is t0 plus h. Now I'll ask you the question, what is the distance? As I said, the distance will be simply this, say, h. So what is the distance here? OP. As I said, OP is a function of time. I'm saying that everything is a function of time here. So let us take a function. The distance is a function of time. OP is ft0. What about OQ? Same logic. OQ is what? Function of time. So now what is the time at Q? T0 plus h. So T0, so you have taken some extra time h. Of course, you have traveled a distance, so you have to have an extra, time. Now, so you have OP and OQ. Now I ask you, what is the PQ distance? You can easily tell OQ minus OP. As I already told you, it is a h distance. You know that it is going to be h. So what is the distance? ft0 plus h minus ft0. So PQ is the distance, right? Distance. Okay. Speed equals distance by time. I just told you that distance is the function of time. So PQ is ft0 plus h minus ft0. Now what is the time? T0 plus h at point Q. T0, the time at P is T0. So 2 hour for point Q, 1 hour for P. So 2 minus 1, 1. 1 hour. So the distance I told you, we traveled certain distance. And for this h, okay, h is our T0 plus h minus T0. That is OQ minus OP for the time. The time is what? H. So the time as per this, don't worry about this distance or time. Just worry that we are finding out the distance in terms of time as a function. We are trying to find out the time for time. So this ft0 plus h minus ft0 by h. So now I want you to find out the time or distance speed at one point. I don't want P and Q. I'm just asking you, go anywhere. If I ask you the time, you have to tell me. Distance, you have to tell me. So this P and Q are two different points. Let us make them one. Is it possible that we can make this P and Q come closer, closer, closer so that become one? Right? So when this becomes very close, that is Q tends to P, that is OX, P also here, Q also here. So this P and Q, you can tell exactly the time, speed and the distance. So Q is actually tending to P, or you can say P is tending to Q. So this H is, as I explained you, I can take it as a distance, I can take it as a time, it doesn't matter. Ultimately this PQ becomes 1, H is going to be 0, there is no H, because PQ are together. So we can apply the limit here, limit H tends to 0. So when we apply this limit H tends to 0, this speed, now T equals T0, T0 plus H, T and T0 plus H are same. So you are actually trying to tell me the point P and Q together, there is some point, you are able to tell me the speed precisely. You can tell me the time, speed, distance precisely. This is the derivative. So this f dash t0 is nothing but f t0 plus th, t0 plus h minus f t0 by h, limit h tends to 0. This is derivative. Now I'll give you a proper example. This was just to understand, make you understand. Now let us take the actual problem. So we have the distance ft in meters moved by a particle traveling in a straight line in t second is given by a function, which is t square plus 3t plus 4. Find the speed of the particle at the end of 2 seconds. So I have given you a function. I want you to precisely tell me what is the speed at 2 seconds. Now this 2 seconds can be 3 seconds, this 2 can be 1.5 seconds, this t can be say 5, 20, 50 seconds. Now you can precisely tell me what is the value. So now if you have a different type of curve, which is not a straight line, and now you can tell me that exact point, whether the curve is straight or anywhere, you can tell me using this discussion. For example, the ft, so you are basically trying to find out f dash 2. That is the derivative of this function at point 2. So what is the function? F x plus c minus fc by h. Remember first discussion? So f2 plus h minus f2 by h, limit h is tending to 0. limit h is tending to 0. So wherever you have t, just put 2 plus h. That is 2 plus h whole square plus 3 and 2 plus h here and plus 4 and this whole minus f2. That is put 2 wherever t comes. So I just put 2 t square. That is 2 square plus 3 into 2 plus 4. What do you see here? I'm not going to solve this. I'm going to give you the exact result. Okay. That is just open this 2 square plus h square plus 2 into 2 4h plus 6h plus 4 6x plus 3h plus 4 minus 4. That is all will be 14. 2 to the 4, 6 and 4. So it is going to be minus 14. So this is going to be h square plus 7h because 14 gets cancelled. And then this 4h and 3h will be 7h. So h square by 7h you'll get. And of course, we have this h in the denominator. Remember, we have h in the denominator. Now h square plus 7h is going to be what? Take h common from here. Take h common. So h plus 7 it will be. H gets cancelled. H plus 7. So apply the limit. I'm taking limit here, but you have to apply in h plus 7. So 0 plus 7 is 7. So this is the 7 value, which is the derivative of this function at 2. So you are able to tell me the exact ft function or speed at time 2. If I ask you 3, 4, you are able to give you. This is the derivative. This is the actual physical interpretation of the derivative. Now, in order to understand more, let me take you a step ahead for geometrical interpretation. Well, how do you see it in geometry? Because you know the geometry, because your graph is not very straight line now. You have to have some kind of curve, and then we need to find out a derivative at a point. So the geometrical interpretation will be something like this. Let us take, everything is about function. So y equals fx is your function. It's a differentiable function. Now I want to ask you that if you have a curve like this, y equals fx. Now this is a curve. It will be something like this, not a straight line. Now y equals fx here is your function. Now take a point, certain point. And you know by previous discussion, this first point, say it's, what is the point? C is your x coordinate. What is the y coordinate? Fc, because y equals fx. So when you put this x as c, fc will be the y. So c and fc are your x and y coordinate. For example, in any graph, if you take any point, say x coordinate and y coordinate 2, 3 like this. So we are taking x as 2, x as c, and y will be fc. Now let us move ahead. Let us go ahead. So take some other point, say this point. So I will ask you, what is the value of y for certain x for this? Say I extended my distance, because this is the distance I'm traveling as we took in the previous discussion. So at this point I'm taking, what is the x and y value? This is c, say we traveled for h distance. So this will be c plus h. Okay. Now the x point will be c plus h because c is the x coordinate, you traveled for h more. So c plus h. So x coordinate will be c plus h. And what is the y coordinate? Of course, you put x as c plus h, it will be fc plus h. Okay. This is c, this is h. So this point is c plus h. What is the y point? Of course, put x as c plus h. Y is x for fc plus h. Y is fc plus h. So now you have the x and y coordinate of both the points. Now the question here is, one is p, one is q. Now I want you to have this p and q together, because I am asking you only one point. Tell me at this point what will be the value. So what is the geometrical representation? I'm not talking about 2 points. Please remember, any point instantaneous speed, instantaneous value, that is at that particular point. First, let me find out the slope. What is the slope here? There is a triangle being formed. This is a point, this is h. What is this point? This is the y difference. Okay, what? Because the y point was fc and the above point was fc plus h. I'm taking the y difference because this is the y coordinate point. This is fc, this is fc plus h. So fc and fc plus h, basically fc plus h minus fc is the distance. So fc plus h minus fc is the y distance. And what is the x distance? It's h. So we have to find out theta. What is tan theta? Tan theta is perpendicular by base. That is fc plus h minus fc divided by h. This is tan theta. So this tan theta, now I am not asking about 2 points. I am saying just p and q should be together. 1 point I am asking. I want to give you only 1 point and you need to tell me the answer. So P and Q has to be 1 point. So when P is Q are together, there will be no H. There is no distance traveled because you have never traveled a distance. So P and Q are together, so H will be 0. So you have to not put H as 0, but limit H tends to 0. H has to be very, very small. So limit H tends to 0. We cannot put H as 0, but this P and Q distance is very, very small. So this is a slope. Tan theta is slope. Tan theta is M. Tan theta is the slope of what? Its derivative. This is the derivative. Basically, it's a slope of the tangent. So the derivative of a function fx at a point x equals c is the slope of the tangent to the curve y equals fx at point c in fc. So take that point, 1 point, that is c comma fc, mark a tangent, draw a tangent. Whatever is the slope of this tangent, m, the value of m, and that is the derivative. That is the derivative of this particular function. Okay, so it's the instantaneous. Any point I'm asking you, and you're very now confident to give me the value. Now let me give you an example of this particular thing, because only telling mathematics will not solve our purpose. So we have to find the slope of the tangent to the curve, and the slope of the tangent to the curve is given as y equals x squared. Y equals x squared. And you have point as minus 1 by 2 and 1 by 4. So how do we find out? So you have y equals x squared, the function is available to us. And also the point, there is the x and y point is also known to us. Okay, y is x squared, that is you are for fx, having y as fx only. Fx x squared. So essentially you are trying to find out f dash at point x, that is fx you have to find out. X point is what? In this xy coordinate, x is minus half. So you are trying to find out f dash minus half. I don't know what kind of curve it is. Okay, let us assume it to be any curve. So I have this point minus half and 1 by 4, and I'm trying to find out the tangent and slope of this tangent. And we know by the discussion we just had, what is the value of this tangent at x and x value. So fx you have to find out. Don't worry about the y value, only worry about the x value. So f dash minus 1 by 2, we have a formula. We just derived it. So fc plus h, so c, that is the constant here. As I said, you have to take the minus half. So this is minus half. H will remain like this. So fx plus h minus fc, this is fc plus h minus fc by h. So minus f minus half plus h, that is, this is your point, fc plus h, c is minus half, and limit h tends to 0. Now wherever you have minus half plus h, please put it in x square. So minus half plus h whole square minus, again, minus half, put in the function, minus half whole square. I'm just telling you the answer. So, because I just don't want to get into the detail of this solution, just come into the solution, h square minus h by h, you can take common, it is going to be minus 1. So the slope is minus 1 from the positive x-axis. So essentially, we have found out the derivative f dash minus half of this function, that is the value of this function at minus half derivative. So this is minus 1, and minus 1 is nothing. What is this minus 1? Minus 1 is tan theta. When will be the theta of tan is going to be minus 1 at 135 degree from positive x-axis. So this is the physical interpretation and geometrical interpretation. Now differentiation from first principles. This is the basic derivation of a function fx. So when we discussed about derivation at function at a point, that means there is a point, say c, in the interval a comma b, and this is a function we have. So we said fx minus fc by x minus c, and this whole limit, the c has come from the a and b, the interval in which this fx is defined. So we said that this is the whole derivation, and we called it as f dash c, f dash for the differentiation. So this f dash c is the differentiation at certain point c. So we talked about the physical interpretation, the other geometrical interpretation also we saw. So finally it came that f dash x is d by dx of fx. Fx is what? Y. So dy by dx. Ultimately we talked about dy by dx. So what is this dy by dx? When we talked about physical and geometrical, we realize that this differentiation f dash x dy by dx is x plus h minus fx by h divided by h, and here limit h tends to 0. H is very small, so limit h tends to 0. So this thing we discussed a lot, and then we realize that this whole is nothing but first principle. Okay, this is the first principle, and this is also the differentiation. So whenever you are being said that d by dx of some function e to the power x, so you have to do it by fx plus h minus fx by h. This is the only way. But since we have already done this, that I'm going to tell you each and every function. So whenever you do this differentiation, you don't have to do it again and again by this first principle. So I will tell you all the functions one by one, and we'll use it by, and finally we will devise that this is the differential of this particular function. So whenever we are dealing with these differentiation or all the functions we are going to take, there are certain things which are going to be very handy. So these are very helpful in finding the first principle example. So sin a plus, these are all the things which are we are going to use. So sin a plus minus b is sin a cos b plus minus cos a sin b. This is what we are going to use. The multiple relationship which I am going to tell you, we are going to directly apply. I am going to tell you, you have to remember all this. Cos a plus minus b is cos a cos b. When left is plus, right will be negative. When left is negative, right will be positive. So you have cos a cos b and minus plus sin a sin b. So cos a cos b minus plus sin a sin b. So there are certain others like tan a plus minus b. So this will be tan a plus minus. I am telling you both plus and minus in the same relation. The denominator will be 1 minus plus, left plus, right minus. So 1 minus plus tan a tan b. Okay, this is the third one. Then the fourth one is, you have tan, this was tan a plus minus b, this is tan a plus minus tan ab. Tan a plus minus tan b. So this will be sin a plus minus b divided by cos a cos b. Cos a cos b. Then you have tan a minus tan b. We have already seen tan a minus tan b, but this is a different way of showing it. So this is also we are going to use sometimes. Tan a minus b and multiplied by, in the bracket we can write it as 1 plus tan a tan b. This also we are going to use. Then sin c plus sin d, sin c minus sin d, and cos c plus cos d, cos c minus cos d, all this we are going to see. So sin c plus sin d is equal to 2 sin c plus d by 2 and cos c minus d by 2. Then we have this sin c minus sin d. So this is going to be 2 sin c minus d by 2 cos c plus d by 2. Please remember, 2 sin c minus d by 2 cos c plus d by 2. Okay. These you have to remember, because until and unless you know this, we are not be able to solve that all the differentiation. Now cos c plus cos d will be 2 cos c plus d by 2 cos c minus d by 2. So this is 2 cos c plus d by 2 cos c minus d by 2, and the other one is cos c minus cos d, and this is going to be cos c minus cos d will be minus 2 sin c plus d by 2 and sin c minus d by 2. Okay, this negative can be taken inside because sin minus theta is minus sin theta. So you can always write it as 2 sin c plus d by 2 sin d minus c by 2. Sin d minus c by 2. Okay. The next one is 10th is 2 sin a cos b, and this will be sin a plus b plus sin a minus b. 2 sin a cos b will be sin a plus b plus sin a minus b. Then we have the other one. You can have this, we have already taken 2 sin a cos b. So let me take as 2 cos a cos b. There are other also, 2 cos a sin b, 2 sin a cos b also. So we have 2 cos a sin b, and this is going to be cos a minus b. This is for 2 cos a cos b. Okay, this is not for 2 cos A sin B. This is for 2 cos A cos B sin A plus B plus sin A minus B. So just I just need a correction there. The 12th one is limit x tends to A, and this we are going to use multiple number of time. In fact, for the first derivation we are going to use this. X raised as n minus a raised n by x minus a and a raised by n minus 1. Now we have sin x. Limit x tends to 0. Sin x by x equals 1. That is limit x tends to 0 or theta tends to 0. Sin theta by theta equals 1. You can also have this kind of where x is not equal to 0. X is tending to a. So sin x minus a by x minus a is going to be 1. Similarly for tan also we have. So tan x by x, and now limit x tending to 0. So this is going to be 1. And limit x tending to a, tan x minus a by x minus a equals 1. And now we have a to the power x, e to the power x, log x also. So this we are going to use pre-made. This already we have proven. So a raised x minus 1 by x, limit x tends to a is going to be log a. Please remember the base is e, natural log it is. This is very important. Base is e. Sometimes the base may be different. Now the other one is limit x tends to 0. E raised x minus 1 by x. E raised x minus 1 by x equals 1. And the final one is log. This is natural log. Log, base e also you can use for log, for natural log. Log 1 plus x by x is equal to 1. So all these we are going to use directly. And whatever derivations I am going to tell you, these have already come in the examination. All have come in some or the other examination. So you have to be very, very comfortable in solving this in first principle. You don't have to solve it again and again, but I'm just saying that you should know how we have to derive so that you know what we are doing. So d by dx of x raised to n is the first function. It is equal to nx raised to n minus 1. The answer is nx raised to n minus 1. So how do we get to this equality, this relationship? So we will do it by first principle. Okay. So x to the power n is fx. X to the power n is fx, right? And now this n is a real number belonging to a real number, and differentiation of x to the power n with respect to x. Please remember we are differentiating with respect to x. So around 10 relationship I am going to do it by this first relationship. So when we have d by dx of y raised to x, we are differentiating with respect to x, not y. Y you have to take constant. Please remember, here only x you have to control, x you have to do, y and other things are constant for you. You don't have to worry about this. Only see x when you are differentiating with respect to x. So now d by dx of x raised to n is what? See, d by dx of x raised to n is, of course, fx is fx plus h minus fx by h, and this is going to be limit h tends to 0. So this is f dash x we are trying to find out, d by dx. So what is fx plus h? In place of x you put x plus h. So x plus h to the power n minus x to the power n. So x plus h to the power n minus x to the power n by h. Limit h tends to 0. This is our first principle. Now how do we do this? The first thing is, you have h in the denominator. You can write this as h, x plus, you can add and subtract x. Now you can cancel it. So h will be x plus h minus x. You can always write it as x plus h minus x. So in place of h, you can write x plus h minus x. So now if you remember, I just gave you certain relationship. This 12th one was x raised n, a raised n, x minus a is n a x n minus 1. So this is going to be, say, assume it to be any variable. Say, assume it to be x only, don't worry. X to the power n minus a to the power n. Here x is a. So, and this x minus a type. So now the same relationship is there. So what is the result? N a to the power n minus 1. As I told you, n a to the power n minus 1. What is? X is n here. So n, what is a? As I said, x is n here. So this x is a. So n a to the power n minus 1. So in place of a, you are going to put x. So n x to the power n minus 1. So n x raised to the power n minus 1. Clear? And x plus h minus x. This whole d by dx of x raised to the power n. When we did, I'm giving an example, x to the power 5. How are you going to do this? This is n a to the power n minus 1. N 5 is coming outside, and x to the power n minus 1, 5x to the power 5 minus 1, that is 5x to the power 4. So this is a differentiation you can directly apply. Now same way we are going to do others only. So the second one is d by dx of e to the power x. How we are going to do this? D by dx or e to the power x. So e to the power x is the result. The answer is differentiation of ex is ex only. So we'll apply the first principle, d by dx of fx. We know already how to do this, fx plus h minus fx by h. So I'm writing it one more time, but for other 8, we will not be writing it again and again. You have to remember that always we are going to take this relationship, limit h tends to 0, fx plus h minus fx by h. So y is fx, which is e to the power x. So this is your fx plus h, means just put x as x plus h here. X as x plus h. So e raised x plus h. In place of x, replace x by x plus h. So e raised x plus h and minus fx, that is minus e to the power x, and then you have h in the denominator. Now limit h tends to 0. E to the power x and e to the power h, you can write it as e to the power x into e to the power h. It is not x to the power h, it is e to the power h. Because x to the power a plus b is x to the power a dot x to the power b. You can always write this. So this is e to the power x dot e to the power h dot minus e to the power x. Now we'll take e to the power x common. So when we take e to the power x common, it will be e to the power h minus 1. I'm writing x to the power h, I'm just going to change it. I'm just going to change it. So this is e to the power h minus 1 by h, and we know that e to the power h minus 1 by h, this also already I told you that e to the power h minus 1 by h is what? Is 1. If you remember, this we did e to the power x plus h as x to the power e to the power x e to the power h. This I already told you. Now e to the power h minus 1 by h, let me take you here. This 16th one, e to the power x minus 1 by x is 1. Limit is x is tending to 0. Just write it here. This is 1. This whole is 1. Okay. What is remaining? What you have taken outside? E to the power x. This is limit x. This h tending to 0. E to the power h minus 1 by h. So this is going to be 1. Only e to the power x remains. So this is how d by dx of e to the power x is e to the power x. This is by first principle. Now coming to the third one, which is a to the power x. D by dx of a to the power x. So d by dx of a to the power x, let me tell you the answer. The differentiation of this is a to the power x log a. But the base is e. This is a natural log. A to the power x log a is the base. So now we have limit h tends to 0. I am directly writing it a to the power x plus h, that is fx plus h minus fx. This is fx, so fx plus h is a raised x plus h minus ax by h. Now a to the power x dot a to the power h minus a to the power x by h. Now you can take a to the power x common. A to the power x common, you will have a to the power h minus 1 by h. So apply the limit. Now you know a to the power h minus 1 by h. A to the power h minus, that is a to the power x minus 1 by x is what? Log a. Base is e and log a. So what do we get it? A to the power h minus 1 by h is log a. Just write it as log a. But base is e. Let me just show you here, because we already did this. This is log a. Base is e. So now just replace this. So this is log a, base is e. Please remember the base is e, because the next question will be changing now. This log will have an effect. Now next one is, what is the differentiation of log x? So what is the differentiation of log x? Log x, base is e. This is a natural logarithm. So this is going to be 1 by x. How we are going to get this? So same thing we are going to do, fx plus h minus fx by h. So let me write it directly. Limit x tends to 0, log x plus h. Wherever x is there, replace it by x plus h. So log base is e, x plus h minus, this is log x and divided by h. So what do? You see, log a minus log b is nothing but log a by b. Log a by b. Okay, log a minus log b is log a by b. So this is log x plus h by x. Log x plus h by x. So log x by x is 1 plus h by x. Log 1 plus h by x you can always write. Okay. So now this whole I am replacing it by log 1 plus h by x. Now we have in the denominator log 1 plus x by x is what? Is equal to 1. We already seen this. So log 1 plus h by x, now you need h by x here. So we are dividing by x, multiplying by x. So now if you see, if you apply the limit x h tends to 0, limit h tends to 0. This whole is going to be what? If you take log, this is k, log 1 plus k by k is 1 if k is tending to 0. So this is going to be 1. Only 1 by x is remaining. So this 1 by x is the answer here. Now this was for natural log, d by dx of natural log. What about d by dx of log which is having the base a? Please remember the base is not e, the base is a, log ax, a is the base. So we'll apply the direct formula here. So limit h tends to 0 and the answer is 1 by x log a, base is e. So how do we get it? Limit h tends to 0 and fx plus h minus fx by h. So x plus h, fx plus h minus fx by h. So what is x plus h? Log base is a, x plus h. And you have to write base a. Log a, base a x and divided by h. And since we already saw in the previous question, log a minus b is log a by b. So you can write it as log base is a, x plus h by x. Log x plus h by x. Now you can write it as x by x is 1 and h by x. Always you can write it as x by x is 1 and this is h by x. So log 1 plus h by x. Now base is a. Now if you see log is this base is a. Log base is a and whatever k is there, you can write it as log k goes up and a goes down. So log k by log a. Now you can write it as base e. So in order to convert a log of any base to e, you have to do this. So we can write this as log, I am taking the base e and since it is log a 1 plus h by x, so log 1 plus h by x divided by log a. So now h is there, divide by x, multiply by x, this whole by log. So log 1 plus h by x by h by x, what it will be? If you remember, it's going to be 1. Log 1 plus x by x, limit x tends to 0 was 1. Log 1 plus x by x is equal to 1 when x is tending to 0, or you can write it as 1. What is in the denominator? Only remaining is 1. If you see, remember x is there and log base e a. So this is the final result. So only one thing is the base was e in the fourth and in the fifth the log, the base is a, not e. So you have to convert it into e first, then you will do the final result. Now the sixth one. So d by dx of sin x. So it will be cos x. The result is cos x. So how do we do this? We'll use the direct formula. So fx plus h minus fx by h. So sin x plus h, wherever x is there, we are putting x plus h. Sin x plus h minus sin x by h. So what is this will be? Sin c minus sin d formula. As I told you already earlier, it will be 2 sin c minus d by 2 cos c plus d by 2. 2 sin c minus d by 2 cos c plus d by 2. So 2 sin c minus d by 2. So x plus h minus x. X plus h minus x. X gets cancelled. It will be h by 2. Sin h by 2. And what is cos? Cos c plus d by 2. X plus h plus x by 2. So 2x plus h by 2. So this will be 2x plus h by 2. Okay. Now we have already have a h in the denominator. So when you have h in the denominator, divide by 2, multiply by 2. Now this whole, when you apply the limit, sin theta by theta, limit theta tends to 0 is 1. So this goes 1. This goes 1. This gets 1. 2 gets cancelled. Only cos 2x plus h by 2 remains. So now you have to apply limit again here to cos 2x plus h by 2. So this h becomes 0. 2 gets cancelled because it is 2x by 2. So only cos x will come. So this is cos x. Sin x differentiation is cos x. Now the seventh one. So we have d by dx of cos x. Now this is going to be not sin x but minus sin x. Please remember, it's going to be minus sin x. So let us apply the first principle. Limit h tends to 0. So fx plus h, that is cos x plus h, minus fx, that is cos x, and divided by h. Now you have to use cos c minus cos d. Cos c minus cos d is minus 2 sin c plus d by 2 sin c minus d by 2. Cos c minus cos d is minus 2 sin c plus d by 2. That is 2x plus h, x plus h plus x. 2x plus h by 2. And you have sin x plus h minus x is h by 2. Sin h by 2. And h is already there. So you divide it by 2, multiply it by 2. So this sin h by 2 and h by 2, limit, you apply the limit, this is going to be 1. 2 gets cancelled, only minus will remain. And sin 2x plus h by 2, now you can apply limit also here. I'm not writing the limit, I'm just telling you. So 2 gets cancelled, so minus sin x. I hope you have to write every step. I'm just doing it fast because we don't need much, we don't spend much time to understanding this. But you have to write each and every step when you are going in the examination or wherever you are writing. I'm giving you just the idea how it has come. Okay. So next one is our d by dx of tan x. So d by dx of tan x. Tan x is sec square x. It is sec square x. Okay. Sec square x is, so we'll apply the first principle, limit h tends to 0 and fx plus h minus fx by h. So tan x plus h minus tan x by h. So tan a minus tan b we are going to use, or rather you can use this cos also. It's easy to make it as sin cos. So tan x plus h can be written as sin x plus h by cos x plus h and minus sin x by cos x. You can apply this tan formula also, but we don't see a need. That is why we change it into sin by cos. Sin by cos. So now just take the LCM. So it will be sin x plus h multiplied by cos x. And here this is done. Now minus other one, cos x plus h sin x and divided by h is already there. I'll take it some other time. Cos x plus h. Now what is this? Sin a cos b minus cos a sin b. And we have seen that this is sin a minus b. Sin a cos b minus cos a sin b is sin a minus b. So just use it sin a minus b. Sin x plus h minus x. So x plus h minus x, x gets cancelled. You only have h. Okay. Now if you remember, there is already an h in the denominator. So I'm just keeping this, shifting this cos x and cos x plus h. You already have h here. So sin h by h is what? This is going to be 1. Sin h by h is 1. And 1 by cos x, we have already applied the limit for sin h by h. Now when you apply a limit here, h will be 0. Cos x is there. Cos x and cos x is cos square x. So it will be sec square x. So step by step you have to apply limit 2 times. I just, because we are just going through this. Ninth we are taking d by dx cot x is, this is going to be minus cosec square x. D by dx of cot x is minus cosec square x. So we are applying the limit now. So limit h tends to 0, cot x plus h minus cot x by h. I am doing it by first principle, fx plus h minus fx by h. So cot, again change it to cos by sin. So it will be cos x plus h by sin x plus h, sin x plus h minus cos x by sin x. Okay. So now just take the LCM. So this will be sin x cos x plus h. This is cot x. Okay. So cos by sin. So sin x cos x plus h minus cos x sin x plus h divided by h is already there. We are not going to write it right now. Next step I am going to write. So we have sin x plus h. Now you see the numerator, sin a cos b minus cos a sin b. Sin a cos b minus cos a sin, what is this? This is sin a minus b. This is sin a minus b. So you have sin x minus x minus h. Okay. So x minus x minus h. X gets cancelled, you get minus h. So you have sin minus h divided by h is already there. I am using this h now. And we have the denominator 1 by sin x plus h. X plus h. Okay. Now this sine minus theta is minus sine theta. So you can take negative outside. Minus sine theta. So minus sine theta, sine h by h. And this is applying the limit. This is sine h by h is going to be 1. Minus 1 will remain. What about the denominator? Sine x. And if this is sine x plus h, put h as 0. So sine x is sine square x. So 1 by, this is sine square x. 1 by sine square x. So minus 1 is there. So minus by sine square goes up. It is cosec square x. So minus cosec square x. This is your dy dx of cot x equals minus cosec square x. So there are around 11 I said. Let us do two more. So we have d by dx of sec x. This is going to be sec x tan x. So sec x x plus h minus sec x by h and d by dx. So that is limit h tends to 0. First principle we are going to use. Now let us change it into cos. 1 by cos x plus h minus 1 by cos x divided by h I am going to take later. Now take the LCM. So cos x minus cos x plus h divided by h cos x plus h. H I am going to use later. H is already there. So cos c minus cos d. Now cos c minus cos d is 2 sin c plus d by 2 sin d minus c by 2. Please remember, it's 2 sin c plus d by 2, 2x plus 2x plus h by 2 and sin d minus c by 2. So x plus h minus x will be there, not x minus h. It will be x plus h minus x. So otherwise it would have been negative because sin d minus c by 2 we are using. So now we have h already there, divided by 2, multiplied by 2. This goes 1, sin theta by theta is 1, 2 gets cancelled. Here sin 2x plus h by 2. And already we have cos x and cos x plus h in the denominator. Whatever is done is done. Now let us write this here. So let me write it here. So sin 2x plus h by 2. And when we apply the limit, h is going to be 0. So it will be sin 2x by 2. That is sin x will come in the numerator. Denominator you have cos x and cos x plus h. Apply the limit, h is 0, sin 2x by 2 is sin x, and cos x is cos square x. Cos x is cos square x. So you have sin x by cos square x. So sin x by cos x we can take as tan x and 1 by cos x as sec x. So sec x tan x has come. So this is d by dx of sec x and sec x tan x. Now this is last but not the least. One more we are going to do to complete everything. This is d by dx of cosec x is equal to minus cosec x cot x. Minus cosec x cot x. Why I am telling you all this? Because once you do the problem, you don't have to worry about the first principle now. You can apply the limit, especially in the higher classes. You can just apply the direct differentiation value. So d by dx of cosec x plus h, that is fx plus h minus fx by h. This is fx plus h minus fx, that is cosec x divided by h. Now just convert it into sine. 1 by sine x plus h minus 1 by sine x and then divided by h you have. H I'll deal later. So just take the LCM. So sine x minus sine x plus h divided by sine x plus h. Sine x plus h. So if you see here, h, let us have h also. Now sin c minus sin d. I told you sin c minus sin d was what? Sin c minus sin d is 2 sin c minus d by 2 cos c plus d by 2. So it will be 2 sin x minus x minus h by 2, that is 2 sin minus h by 2 and cos 2x plus h by 2. So you have h here. Either you can have a negative here and multiply negative in the numerator. So minus you can have numerator denominator, then you can have 1, or you can take minus out of sign also. So you have this as 1 cos 2x plus h by 2. Denominator you have sin x plus by 2. Just apply the limit. Negative is already there. I'm not writing negative. I'll just write negative. Let me solve this. H is 0. 2x by 2 is cos x, sin x, and cos x plus h. H is 0. So sin x will come only. H is 0. We have sin x. So cos x by sin x. So cos x by sin x is cot x. And cosec x 1 by sin x is cosec x. So now let me tell you about negative once again. Sin minus h by 2, when you have a negative in denominator, when you by yourself you have put minus, you have to have a negative in the numerator also. So it will be negative. Otherwise, you can do the one thing, sin minus theta is minus sin theta. You can take minus outside. That is how minus has come outside. So sin minus theta is minus sin theta. This is what you have to do, right? So this minus cos by sin is going to be cot, and 1 by sin is going to be cosec theta. We are going to see the product rule and quotient rule of differentiation. Before that, let me just quickly tell you about some theorem that d by dx of a constant value, any constant value, is going to be 0, like d by dx of 5. This is a constant value. It's going to be 0. Also, if we take the differential or differentiation of a function, and we have a constant here along with this function with multiplicative property, that is, it is multiplied by this, you can take this c outside and you can divide this d by dx, and then 5x square is a function, for example. 5 you can take outside. In x square you can do, x square is nx raised n minus 1, so x, 5 into 2 into x, that is 10x will come. Now coming to today's point, the first one is product rule of differentiation. So this is product rule of differentiation. What does it do? We have two different functions, they are multiplied, and then you have to find out the differentiation or derivative of this combined value. So d by dx of two functions, one function, let us say fx, the other function is gx. So what we are intending to do is differential of two functions which are multiplied together. So how do we do this? First take fx outside, write this fx, then next time you take this gx outside. First fx outside, then gx outside. Then what is remaining? If you take fx outside, gx will remain. So d by dx of gx. Similarly, when you take gx outside, it will be d by dx of fx. So this is the product rule of or for differentiation. Let me give you an example. It will be better to understand with an example. So we have x sin x. We have a question, example, x sin x. Now we have to use the product rule. So x is fx and sin x is gx. So these are two separate functions, and we have to find out the differentiation of these two or this combined value. So as I said, let us take fx outside first. So x we are taking outside, d by dx will be of sin x, then plus, now you can take this sin x outside, and now differentiation of what will be done? X is remaining, so x will be done. So this is the product rule we have applied, and now let us see the value x. Sin x is cos x, d by dx of sin x is cos x, then sin x is already there, and d by dx of x is 1. d by dx of x is 1. So here x cos x plus sin x, this is the product rule we have applied. Now coming to one more important aspect of differentiation, we are going to use it for multiple questions after this. So we have quotient rule for differentiation. So QUOTIENT, quotient rule for differentiation. So if fx and gx are two differentiable functions such that this gx is not equal to 0, the function which is in the denominator is not 0, then we have to show, or we have to write like this: d by dx of fx by gx. Gx should not be 0. So what we'll do, first we'll take gx, take in the denominator and square it. Gx and just square it. This is, now same thing, gx you have to start with gx now. You have to start with gx. So gx, now same multiplication type thing you have to do, product type you have to do with a negative sign. So gx, so gx, now what will be inside d by dx? It's fx. Now as I said, just change the sign, negative, it will be negative. Now take fx outside and d by dx of gx. So this is the formula of quotient rule for differentiation. So we have to start with the denominator, square it, put it in the denominator. We have to start with the gx. Whichever is the denominator, you have to start, and then you know how to do this. Just flip it. Okay. So we'll take one more example for this quotient rule to elaborate. So let us take a function called e raise x by 1 plus sin x. E raise x by 1 plus sin x. So now this is e raise d by dx. If we have to find out, this ex is your fx and 1 plus sin x is your gx. So as I told you, first in the denominator take this gx 1 plus sin x and square it. We don't have to do any differential here, only just square it and start with this one only, 1 plus sin x, then d by dx of what? The g, because ex is remaining, so ex, now negative sign, subtraction, and since we have done already this thing, ex, so take it outside, and now 1 plus sin x has to be differentiated. So let me take this 1 plus sin x and d by dx of ex, or d by dx of ex is ex only. So just write e to the power x minus e raise x and d by dx of 1 plus sin x. How to do this? 1 plus sin x, 1 d by dx of 1 plus d by dx of sin x. So d by dx of constant is 0 and d by dx of sin x is cos x. Sin x is cos x. So just cos x, and now you can have this, let us do it. You can take e raise x common and it will be 1 plus sin x minus cos x. What I am suggesting is multiply ex inside, ex plus ex sin x minus ex cos x, and now you can take ex common from each term. So e raise x you take common, you will be having 1 plus sin x minus cos x and divided by, it was already there, 1 plus sin x whole square. Okay, so this is the final result. So what we have seen is product rule and quotient rule of differentiation. Thank you so much and take care of yourself.